Thank you all very much. Thank you, Dr. Chang, and everyone else that invited me here. They were very gracious to have me here. I apologize several times. My wife was supposed to come with me but didn't make the trip, but thank goodness she was the reason I'm here, so I appreciate her as well. And we'll start off. I apologize in advance to the translators and to your eyes because I'm going to go very fast. I have a lot of material.
Wow.
It's my tendency to have a lot of material, but I've been asked to focus on one of my real interests, which is cybersecurity, that I've been involved with since 1987. I ran the SWIFT network for banking, so we were at the forefront of what we needed to protect a long, long time ago. And I know it's, I call it the soccer ball. Anyone that coaches soccer, if you coach 7- and 9-year-olds, they're all around the ball. And that's what cybersecurity looks like right now. So everyone works on cybersecurity, but I actually do. And I mentioned that I worked on 37 pieces of failed legislation on cybersecurity, but that's not so bad because they've actually failed 108 times to pass any legislation in the United States on cybersecurity. My boss, Dr. Bray, asked me to speak on the Internet of Things as a subject, so I will do that, and hopefully it won't be too painful for you. This doesn't have the advance for the slides. There it is. There it is. So you'll see a lot of definitions, and I'm sorry about that, but I'm going to define the Internet of Things and the Internet of Everything and the Internet of Threats. And I'm also going to show you a lot of slides about the monetary consequences. There's a reason for that, because what it really means is it's about money. And when investment bankers put money in something, it will happen. The Internet of Things was actually coined in 1999 by a gentleman named Kevin Ashton, and he was talking about RFID. So when he talked about RFID, I'm just going to read this to you quickly. He said, if we had computers that know everything there was to know about things, using data they gathered without help from us, we would be able to track and count everything and greatly reduce waste, loss, and cost. We would know what things needed to be replaced, repaired, or recalled, and whether they were fresh or past their best. The Internet of Things has the potential to change the world just as the Internet is now, or maybe more so. And that was in 1999. Certainly wasn't the 1800s for many of the other things that happened, but he was a good prognosticator. The devices are just going crazy. I mean, we're in a position where devices are going to take over. The Internet of Things is defined many, many different ways about physical objects that have the ability to compute, connect to networks, and communicate data. Obviously, in every one of the verbs, there is a cyber issue. So for me, anything that exists or moves has a cyber challenge. So this is the first how big it is. The Internet of Things will be, I actually think it is, a model that will change businesses, technology investments, customer experiences, and everyday life. It's the next phase of the Internet. It will impact everything from new product opportunities to manufacturing automation to worker efficiencies, and it will impact top lines and bottom lines. New businesses will be grown out of building the pipes, building the apps, and analyzing the data. There will be clear benefits, both perceived and real. The analysis portion is very interesting. I'm sure all of you have seen a tremendous number of new tools available because of the cloud and being able to aggregate data. Just as a side note, I had to analyze 4 million net neutrality comments for FCC. And I'm not speaking for FCC here, by the way, just me. And the chairman wanted to know the one comment that had the most swear words in it. He wanted to know the one that attacked his family and any ones that attacked him. And it was only for humor that he wanted that, but we have tools to do all of that and to analyze sentiment, which is all part of the Internet of Things. It's going to have a significant impact on our work life. It is pervasive computing. So as a friend of mine had just launched a company which is in stealth mode that knows exactly where you are all the time, whether your device is on or not. And it's a little scary. So you can turn it off, you can take the battery out, doesn't make any difference. He can track you and know where you are. To some people, this is irrelevant. To me, I've had 4 wives, it's very relevant. They all want to know where I am. So it's very relevant to me. We're going to go beyond connecting to becoming part of a living and moving global digital nervous system. The key word for me there is nervous. This is all-encompassing, and it's a convergence of the physical and digital domains, and it's huge. Okay, so to me, the questions were what made all this possible? And what made it possible, to me, or when I looked at it, was the size and cost of devices went down precipitously. IPv6, which we worked on in the White House for 7 years to try to get IPv6 in as a standard in the federal government, which has been hugely adopted by about 8%. But IPv6, if you look at a beach ball as 4 billion addresses, IPv6 provides 350 trillion addresses. So besides the fact that IPv6 requires much less addressing protocol, it will be one of the facilitators for what's happening with the Internet of Everything. Mobile data coverage, and the fact that electronic companies are building Wi-Fi and cellular connectivity to everything, that's been a huge boost. And battery power. It seems silly, but battery power, as many as mobile makers know, has been one of the largest challenges. And now technology has been developed so personal devices will actually not need a battery and run off your skin. So it's becoming more and more pervasive. So the key components are faster and smaller microprocessors, smaller and better sensors, more ubiquitous and robust wireless networks, expanding cloud storage, and enhancing big data. All of these factors obviously are the things that have made all of this possible. The install base, the size of the market, and sensors. My favorite subject, I relayed a story at dinner that a long time ago, the Department of Defense thought it'd be a brilliant idea to install RFID chips in humans, as in soldiers, so that they would know where they were on the field and they could better control their assets. And they asked me to look at it, and I said, it's the stupidest thing I've ever heard in my life. And promptly I said, I know I could hack it maybe in a week, but I have a 17-year-old that I know can do it immediately, and he did it in 2 hours. So the red team became the blue team became the red team. Not dissimilar from a project I worked on where the logistics for the Gulf War were considered the best logistics of all time because of a brilliant PhD no offense to anyone. I mean, I've never been around so many PhDs, so it's very scary for me. But he was a PhD from Carnegie Mellon who devised an incredible program to be able to deliver things, JIT, just in time for the Army in the Gulf War. The only problem was he left the chips on the trucks and the tanks because he wanted to be able to recover them. So I had to go in and we had a gun developed that would actually blow the chips, electronically blow the chips up once they were there, because obviously anything you can track, somebody else can track. And speaking of your neighbor, we've got in the sensor market, China is spending $600 billion in this market. $600 billion. I think the United States estimate was 10% of that. So they're obviously going to be out there. And the percentage of machine-to-machine connections in China is twice that what it is in the United States. Connectivity is the issue for me. Obviously, cybersecurity risks start at the chip. In a couple of speaking engagements, I said, well, how can you secure a chip when half of the R&D development that we're doing right now on chips is in China and Russia? So if they're doing the R&D development, then obviously the firmware is built onto the chip. So you're starting with vulnerabilities on day one, and you can't cure it from after it's left the factory and after you've installed it. Trying to cure those vulnerabilities is very hard. Sensors transmit data that becomes an information that hits a device or a server that performs hopefully analytics, and it turns the data into knowledge or insight of some kind. Every one of these connections mediate human interactions, and the networks are collaborative, but also a source of opposition and threat. I'm not much on slides, so if I forget, just wave and I'll move on to the next one. Studies have shown that over 70%, and I think this is low, of devices contain vulnerabilities. A good friend of mine who is a PhD at Columbia, he and his team successfully hacked, you probably saw this about 4 years ago, hacked all printers. They could virtually pull anything off of a printer anywhere. And it was a scary circumstance, and of course, being very reactive, the industry did nothing about it, so they can still be hacked. But security of the thing is only as secure as the network it resides on, and this includes the people, process, and technology, not just the delivery. Go back to how big it is. It's big. It's big. You can't ignore it, and we're moving ahead whether we like it or believe it's secure or not. Once again, if I go too fast, tell me, but I'm trying to give you some extra time. The numbers are extraordinary. The interactions created are terrific opportunities. Anytime you have interaction between people, machine to machine, machine to person, there's a revenue opportunity. And anywhere there's a revenue opportunity, somebody's going to jump into it. And there's also a threat opportunity, because anywhere there's money, you can build a threat. As I said before, I can be cynical because I was an investment banker and I've had 4 software companies, so I think I can be as cynical as I want. Wherever investment bankers in Silicon Valley go, it's going to happen. They have billions and billions of dollars to invest in the Internet of Things and the Internet of Everything, so it's going to go there. Luckily, they also are spending quite a bit of money on cybersecurity. They've helped launch 500 cybersecurity companies in the last 30 months. That's a lot of companies. And they vary tremendously from active defense companies to DDoS companies to network support to intrusion detection. I mean, they cover the gambit. revenue and the growth are there. This will be one. This reminds me of the figures here. I did a lot of research on this, and I'll back up. But there was a thing when there was a gas crisis in the United States. They said if you have the right amount of air in your tire, and the car is tuned properly, and you don't drive over a certain mile an hour, each one of those things were identified with a gain in mileage. And if you added it all up, you could get about 150 miles per gallon. So the numbers that they come up with are about the same here. If you actually add up everything they say you're going to do, it actually comes up to more than the entire IT industry now. But in any case, it is big. So worldwide, the Internet of Things market forecast is to grow from 1.3 trillion to 3.4 trillion in 2020, or if you prefer, 19 trillion is the stake of private industry, or if you prefer, 2 trillion. So the numbers are definitely all over the place, but they are in the T's, so the T's count. McKinsey, who tries to be terribly accurate, said that it'll be between 3.9 and 11.1 trillion. That's a pretty big spread. I bet on horses, and a spread like that wouldn't win me anything. So that's hard to do. IDC says 8.9 trillion, and Cisco, point well made, Cisco that would like us to build everything out, and John Chambers is a lovely man, retired, but lovely man. He'd like us to build everything out, so obviously their number is going to be the biggest. So here we get to applications, one of my favorite subjects. We build software with known vulnerabilities. We don't have the discipline to build applications properly. And just to give you a view of how bad it is, right now, or last week, there were 253 billion free apps. Billion. And everybody just downloads them. I mean, just, who cares? I have another app. This is great. My wife makes fun of me. I have 3 apps on my phone. So I'm not a big consumer. But the risk profile on apps is huge. And having worked with, I advise venture capital companies, and I've worked with 7 venture-backed cyber companies, everything from people that monitor the internet, monitor sensors, and it's like a playground. It's really, really scary. And I'm not a naysayer. I think we'll maybe figure it out. But right now, I equate to what we're doing on cybersecurity. On Internet of Things, it's 0 to 10. It's a 2, maybe a 1. The rest of cybersecurity, I equate it to the Mangio line. Anyone that studied history, the French, who thought they were brilliant, decided to build an impassable line of defense after World War I to keep the Germans from just going right through Alsace and going into France. And they didn't want to offend the Belgians, so they left that border open, so the Germans went around. So that's what we're doing right now in cyber, is we're building a Mangio line when all the sides are open. So anyone that wants to do a frontal attack probably would have a really hard time. But there's absolutely no purpose whatsoever into going into a frontal attack. And with 3 billion devices, I'm having a hard time figuring out how we do this unless we start protecting the very things, the sensors that we're building. Since wearables are a tremendous part of this, it makes me even more nervous. Someone swallows an ingestible and someone decides to play with it. I think there was a movie about guys traveling through someone's body to try to fix something. And the idea that somebody else can take control is really bizarre. limbs, ingestibles, implantables, biohacking. All of these things are very prone to hacking. And we also have the spectrum issue, which you all know a lot more about spectrum than I do, so I won't address it. Someone said to me, well, it's a very small amount of spectrum used by these devices. Well, I venture to say when there are trillions of them, it will become an issue. And if there is no spectrum and you have a device planted on your body, you may have a really tough day. So that's going to be a problem. The enormous number of devices coupled with sheer volume, velocity, and the structure of the Internet of Things creates challenges, particularly in the areas of security, data storage management, servers, and the data center network. And all of real-time businesses are at risk. Disruption, just because the faster we go, and people are not going to, if you have small devices, sensors, which is where the Internet of Things begins, how much are you going to spend on a 35-cent sensor to protect it? I mean, that's the problem. Where the sensor goes next is the issue. And as an acquaintance of mine, Kaspersky, I don't know if any of you know him, but he's got a very large cybersecurity firm based in Russia and predicts almost every large cyber incident, which is very intriguing to some people that he's always the guy predicting them. He called this the Internet of Threats. And he's kind of out there, so he knows his stuff, and he operates in Russia. So I think if he knows the threat, probably I'm going to pay attention to it. The transition from the Internet of Things to the Internet of Everything is hugely interesting because when it becomes everything, the network divisiveness and the IDs become transparent. I mean, machines or sensors are talking to sensors and they're not talking to you. The only time you ever find out what's happened is when hopefully it ends up at a database somewhere, and hopefully that database is protected by something or someone. So it's a challenge. The Internet of Things is going to be a considerable challenge, not because security implications are more varied, but because traditional IT settings just won't work. The vulnerabilities of all these core layers, which are the perception and the network and the application, balancing the cost and risk, as I mentioned before, is really the challenge. But the potential damage to people, possessions, businesses, and national critical infrastructure from attack on a cyber-physical system through this emerging Internet of Things cannot be underestimated. I worked with the Department of Energy on the grid and protecting the grid, and I told them after a year just to unplug it. So it's SCADA systems are hard. The Internet of Things is almost imperceptible as to how hard it's going to be. But it's cool stuff. I mean, there's no question that people, process, data, and things come together for a very good outcome, and we're going down this road. If you're asked to do a business case, which I'm asked to do all the time, the business case for the Internet of Things and using sensors is undeniable. I mean, the business cases abound. You can just sit down and write 10 of them as to how sensors can change everything you do for the better. I think when we're talking about embedded securities, I think the embedded part is the part we're missing, in that we have to start at the core. And so hopefully the developers that are coming up will know something about securing devices. Not not all developers are mechanical engineers and electrical engineers. So when they build something, they're either building software or they're building hardware. I worked with one of the most brilliant man I've ever known. His name is Tom Guthrie. He was a lead at Bell Labs, and we developed land-based sonar. And he was a PhD in mechanical engineering. And everyone said, well, you don't know anything about software. And I watched him over a weekend, watching his 3 kids on a football field, write a software program to drive it and drop it on his developer's desk and said, don't ever tell me that I can't do this again. But not everybody can do that. So there has to be this marriage between the physical and the software that is going to be bigger than ever before. I don't know if, when I went to business school, we had to read a book called The Soul of the New Machine, which was all about general data building this huge computer and what happened when they tried to put software engineers together with hardware engineers. It's an intriguing book. I would suggest you read it just because it talks about the problems with human interactions when 2 different groups collide. I was told very interestingly that here it's different. Engineers respect IT and other things, but where I come from, my wife is a EEE and she doesn't respect me at all. I work in IT and software, so hopefully I'm happy to hear that's not the way it is universally. But going back to the benefits, General Electric, that knows a little something about producing things, stated that a 1% increase in efficiency from the industrial internet, which is what they call the Internet of Things, would result in over $80 billion in savings for the oil and gas industry, over $60 billion for power and healthcare, and so on and so forth. So once again, adding up the numbers is a challenge, but GE is a pretty smart company. So the people that are going to make the decisions, this was a survey done, I don't know why the credit fell off, but I didn't do this. Executives are starting to notice, and mainly because of Wall Street and investment bankers, but they are noticing. And if they have these business drivers in front of them, you can bet they're going to do this. I mean, there's just no question they're going there. And the technology drivers, as I said before, are there. I mean, luckily, technology companies have come up with what we need in order to make all of this happen. Metcalfe's law, everybody knows that, but I thought I threw it up there. The connections become more and more valuable the more real-time they are. So, I mean, this goes to our chairman, Tom Miller, wrote a book called Lincoln's T-Mails, about how the telegraph changed the way the Civil War was conducted because he could communicate so quickly with the field. The closer you are to the interaction, the more valuable it is. And that's what's happening with sensors and with the Internet of Things and then the Internet of Everything. Maximizing the value, it's all there. I mean, these are very obvious concepts, and I think irrefutable. So here we have really a map of the problems. You have to protect every one of these relationships, people to people, machine to machine, and people to machine. And each one of those interactions is very different. And each group is using very different devices. Since the mantra is access anything at any time from anywhere, if you apply that to this, you see a huge amount of challenge. Obviously, the biggest breaches so far, other than our recent Office of Personnel Management breach in the United States, have been caused by individuals. Private Manning, Snowden, I mean, it's been individuals providing data that is harmful, at least in the United States. But as far as OPM, the Office of Personnel Management, losing 20 million security records, that interaction was conducted over a very long period of time by what I call intelligent agents. There was a paper written in the 60s about intelligent agents, but basically worms and so forth. They're intelligent agents that know what to do when they get there, and they need no further introduction. We can't let that happen with sensors and the Internet of Everything. So hopefully, our leaders in business are thinking this way. Don't just connect because you can, but think about why you're doing it, what the outcome is. One of the large initiatives in the U.S. government has just been collect data and make data available, like something magical is going to happen just because it's there. And I believe that you need some kind of outcome. And one of the biggest issues beyond cybersecurity that touches cybersecurity everywhere is what are you going to do about our existing laws, privacy laws? We breach them constantly, and I think Google Glasses is a good example. At my gym, you can't bring a phone into the locker room because there are people taking pictures of other people with their iPhones. And so if you have Google Glasses and you just walk around and you don't know what people are doing, and there's a Privacy Act in the United States where you're not actually supposed to be able to collect information, nude or otherwise, without someone's permission. So I'm not sure that we can bet on norms to handle all the issues. I think the issues are going to be huge. I think taking, for example, a very simple break, Target lost a bunch of credit card numbers and was fined $10 or $15 million by the U.S. government. And it hurt the company more than anybody else, and they're sitting around saying, well, why did we get fined? We're providing protection for everybody that got scammed and everything else. When OPM loses 20 million records, what happens then? So this is where all this comes in. The societal and political issues are tremendous. The legal issues in the United States about when you collect data, why you collect it, what it's for, who owns it. All of those are legal norms that are going to be huge in the Internet of Everything. If you start collecting data from everybody, how do you anonymize it? So if there is a breach, what happens? How do you encrypt the data? But ultimately, who owns that data? There are no standard platforms, there are no standard access, whether it's Wi-Fi or Bluetooth. There are no standards in those areas for the Internet of Everything, and that will slow down the progress. But business is business, and there's money in it. So this is where all the money, I mean, the money's in applications, the enablement, infrastructure, and things. And one of my favorite little drawings. So everything is connected in this magical cloud. I was amused because when we had to move FCC's data centers out of the building, they said, I went to the Hill to try to justify why we were spending $5 or $6 million. And they said, so we heard you're moving to the cloud. I said, no, we're actually moving to West Virginia. And it's wild and wonderful, but it's not a cloud. And I said, well, what's the difference? It's not your building. So it's not that there's a universal view of what cloud is. And the converse of that is we put in a system, a very good system for complaints. We did it in 90 days for $400,000 when our long-term contracting firm that's been there 20 years on October 4th, they reminded me of that, they wanted to do it over 18 months for $3.5 million. And I said, I think that's ludicrous. So we put in a SaaS platform, and everyone in the FCC said, oh, Well, where's the service desk? Well, it's wherever it wants to be. Well, who maintains it? Well, it's maintained in the cloud. And the association thing, one of the beauties of the Internet of Everything is the association thing goes away. So with that, I think I'll give you one more, and then we'll have time if you have any questions. I did not go through all 87 slides, but let's see. I know I have an in-closing slide. So all of these things, just imagine traditional challenges, and then add to that what, I mean, the privacy risk, the safety risk, and the automation risks with the ethical issues associated with it are tremendous. Challenges are huge. You have all these slides, so you can look at it later. All of these things, I'm sure you understand. And there we go. It's huge. Thank you.
Thank you to our speaker, Mr. Tony Summerlin.
Any questions?
Yes, maybe we have time for 2 short questions. Anyone who would like to take this opportunity to raise questions for Tony? Yes.
I would like to ask about the personal data protection at the time of IOE. What is your vision on that?
My vision on it is that with 7 agencies in government are in charge of it. So I see it going pretty much the way of our cybersecurity bills. I'm not negative, but I'm just saying that 107 times they've tried to pass a cybersecurity bill of some sort. The privacy issues, everybody cares about privacy for themselves, but they don't care about yours. Which is, so it's, when we had a meeting in the White House where I was lucky enough to be for 8 years, I actually heard people say things like, someone jumped up and said, look, if this meeting is about the CIA lying, DHS being incompetent, and the FBI not sharing, why are we having this meeting? Because that's our job. Sounds like, okay, that's a problem. So the privacy issues, I think you just saw that actually the government lost one round because I testified on this. The government said they wanted a backdoor to all encrypted traffic. And I said, that's a lovely thing, but you put a friend of mine's company out of business because NSA couldn't break his encryption. And that means it's really good encryption. And if we give backdoors to the government, people are really smart. I mean, the Chinese have 40,000 people doing this every day for the government. If we can do it, they can do it. And it was very short-sighted, so luckily that didn't happen. But it's up for grabs. I think norms, the public and norms that they drive will make the difference. Like, why do you have my data? But you've seen what's happened with Google, right? I mean, they Googleized the state of California, and they came to find out that Google was tracking every state employee, knew all their shopping habits, and it was like, oh, wait a minute, that's not, we thought we were just using email and documents, and how to find out how to get to Sacramento, and instead, Google has all the data on everybody. Who owns the data? And whether it's anonymized or encrypted, I think is a huge issue. But encryption at rest, I'm a big believer, encryption at rest is vital. Just if anybody steals it, but who owns it and who owns it in the pipe is huge. I wish I had a better answer, but I'm not optimistic. But it's going to go ahead anyway because the bankers are putting all their money in it. So Internet of Everything is going to happen, so get used to it, and that's just the way it is.
Okay, so maybe due to time, one more very short one, please.
Could you please share with us about the any initiative in FCC regarding to cybersecurity in this era of Internet of Things?
Well, luckily the FCC is very antiquated, so we didn't have a lot, but what happens in FCC is what happens in most agencies, and which is they buy toys, they get a shopping cart, and they go down the street and they just fill it with cyber toys. They just, oh, I'll have one of these, I'll have one of these, and just like anyone that's installed McAfee and Norton and Symantec on their PC, they notice it doesn't work anymore. That's kind of what FCC, luckily, had most of these tools on the shelf for 5 years and never installed them, which is lovely also. Just spend $10 million on stuff you don't use. But it's a discipline, so what I put in was a SOC and a NOC that were very disciplined in their approach and actually did the pedantic work. Nobody wants to do the day-to-day thing. They'd rather look at a big screen of threats across the internet that they can't do anything about. But whether or not you can put in a simple tool to prevent a DDoS or so forth, it's really important. Our Public Safety Homeland Security Bureau, which is run by ex-Admiral Simpson, is in charge of all outward-facing cyber. He would like to be in that arena because it's the soccer ball. But actually under U.S. law, DHS owns cybersecurity for civilian agencies, including telecoms, and DOD owns it for, well, Cybercom, DOD, Title 10, Title 50 are owned in DOD. So we do what we can internally, and we do notify our telecoms of things, but to be honest, Verizon, AT&T, they're really good at cybersecurity. No one gives them any credit, but if you saw what they saw every day, I mean, they're really good at this. Telecoms they're saving our butts right now. I mean, they really are. And the fact that intrusions get in, it's going to happen, but in the Internet of Everything, if it goes through a switch and it happens to be at AT&T or Verizon, you have a much better chance of survival than you do any other way. They're really good at it. A lot better than software companies. Sir.
Okay, so we thank you for your questions, and maybe you want to take one more?
Sure.
Thank you for your generosity. I put it quick and simple. Are you suggesting policy makers could be the so-called police makers, something like that? Big companies or even government, okay, for homeland security reasons. And would that be, in the past, the so-called smoking gun theory won't be useful or be deniable? And the other thing is there could be internal. We're talking about the outside world. This country, so-called Japan, they are building, facilitating middlewares into firmwares, not to mention software and hardware. So what are they up to? Because right now they got internal consensus to march out. So what are you going to do? Sorry. What I'm saying is so-called Yankees. No defense, thank you. Just for the records, thank you.
See, I think the first part is whether the government's going to be policing this or whether the private sector is. Is that right? Yeah. The private sector has to do it. The government has a very bad record of supporting industry. I'll give you an example. A very large defense contractor in the United States was breached, and the government didn't bother to tell them about it, even they knew about it because they wanted to investigate. So there's not a lot of trust there. So companies are going to have to do their own work. The middleware, I don't know what Japan is doing, but in the United States we have, for government, they installed Einstein, which I'm sure everybody's heard of at this point, but they have a scanning capability across networks. But all it does is scan. I mean, it doesn't help you unless someone tells you what's there. So the scanning capability, I mean, what NSA does, for example, throughout the globe, I don't know, but I think it's pretty good. Unfortunately, some of it came to light, and it's maybe better than it should be. But I don't know, installing the middleware throughout the United States to preclude cyber attacks or threats is very far-fetched, I believe. Companies have to do it themselves. Thank you very much. I'm honored.